Our next topic in this course is circle geometry. And in order to be successful, we need to know, be reminded of some background information we already learned, supposedly learned in grade 6, 7, 8, back there in our early years. And so let's just talk a bit about that today, just to make sure we're ready for the rest of it. First of all, we're going to talk about polygons and their angles. Polygons are multiple-sided closed figures like triangles, rectangles, and pentagons, etc. And so if I was to take and try to draw a basic pentagon here, first of all, it has straight sides. All the sides are straight. And so I'll try to make them as straight as I can. And it can look whatever shape you want it to look like. And as long as they're straight sides, and as long as it closes up, so there's no gap. And there it is. There's a figure. It's got 1, 2, 3, 4, 5, 6 sides. And it's closed, and the sides are basically straight. I've tried to make them as straight as I can. That's a polygon. So the smallest polygon possible is a shape that has 3 sides. And so triangle is the basic smallest polygon we make. And the angles, if we look at the angles of a triangle, we can call them, in this case here, the example I've got down, X, Y, and Z. They could be any angles. It doesn't have to be a 90-degree triangle. Any kind of triangle. All the angles always of every triangle add up to 180 degrees. So this is helpful. If I know 2 of the angles, I can find the third. So in other words, if I know X, if I said to you X was, say, 40 degrees, and I told you that Y was, say, 80 degrees, what is Z? Okay, what is Z? Well, I don't know, but can I figure it out? Yes, because all 3 add up to 180. All I need to do is to take and add those 2 together, and the third one has to give me 180. So I just take 180 degrees, subtract 120 from it to see what extra I need. And so that's where Z is 60 degrees in this example. So if I know 2, I can find the third of a triangle, which is very, very helpful at times for solving triangles. The next shape we're going to talk about is a quadrilateral. And this, the angles of a quadrilateral always add up to 360 degrees. So all 4 angles of a quadrilateral, they always have 4 angles, will add to 360. And you can see this in a square or a rectangle. All 4 angles are 90 degrees, and they would add up. 4 times 90 is 360. And it doesn't have to be 90 degrees, but any quadrilateral add up to 360 as well. Which brings us to other shapes. Pentagons, hexagons, 6-sided figures, whatever, and more. And so we've got n equals the number of sides of the shape, and s is the sum of the angles. So the sum, the total of all the angles of that shape. And so there is a equation or formula we can write down. And so what you're going to write here is the sum of the angles of any polygon is equal to the number of sides, and just subtract 2 from it, and multiply that times 180 degrees. And this equation and formula can be written in many forms, but this is what I'm just showing you today. Just multiply that by 180, and that gives you the angles in the shape. So for instance, if it was a triangle, I would put, if it was a sum of the angles of a triangle, I would put 3 in there for the number of sides. Okay, and 3 minus 2 is 1. And that, of course, equals 180 degrees. And that we already have that information. But just to show you, that's the equation, how it works. So let's calculate a pentagon and a hexagon here. Quickly do that. If I have a 5-sided figure, similar idea. Except this is going to be 5 minus 2 times 180. In this case here, I get S equals 3 times 180. Okay, which is going to give me 540 degrees. So this 5-sided figure adds up to 540, and similar with a 6-sided figure, again, same idea. 6 minus 2 times 180, and that's going to be 4 times 180. which equals 720 degrees. So I can do this with any shape. It could be 10-sided, 11-sided, 55-sided, doesn't matter. Okay, just a quick little formula which can be helpful. Generally speaking, in this course, we won't use more than, say, 5, 6-sided figures. It'll be the max, probably. I don't think we'll go any more than that. Going on to the next part here, number 2, special triangles. Let's focus on triangles now. And first one is isosceles triangle. And this means that two sides have the same length. So I'm going to put little lines here. These two lines mean that they are the same length. What about, does this have any other information though? Well, it does. In an isosceles triangle, the two angles that are opposite those equal sides, these angles are also equal. Okay, so that is going to come in really handy later on. We start doing some of the problems from the textbook and in this part of the course. Okay, what about a equilateral triangle? Let's keep moving on here. Well, in this case, all three sides are the same length. So if I can just put little line, this side and this side are all equal. Well, what does that mean about the angles? That means the angles are all equal. So if one was x, the other would also be x, and the other would, so they're all the same. So what does that tell us anything? Well, yes. If I have three angles the same, 3 times x, add them up, 3x and x is 3x. That has to equal what? Well, a triangle adds up to 180 degrees. So how do I find what x is? X is, well, divide by 3. To get rid of the 3, I'm going to get x by itself. 3's are gone. I get x equals 180 divided by 3 is 60 degrees. So in an equilateral triangle, the angles are always equal to 60 degrees because they're all the same and they have to add up to 180. So that's kind of nice. We know the angles of an equilateral triangle, which, again, with certain questions will come in really handy to know that information. Okay, so last little concept here before we do the vocabulary is through the Pythagoras Theorem, or the Pythagorean Theorem. And in this case here, it only works with right triangles. So it has to have a 90-degree angle in it. So let's just put that in here. This is 90 degrees, right? Now let's just talk about the size of this. The side opposite the 90 degrees is called the hypotenuse. We call that letter C. And of course, I hope this is just review. It should be review. It should have done this in grade 8 for sure, if not earlier. The other two sides we just call A and B. It doesn't matter which we label A and which we call B because they are both what we call the legs. And they form the 90-degree angle. Together they make the 90 degrees. Okay, which side's the longest side of a 90-degree triangle? Well, it's always the side opposite the 90 degrees of a right triangle. So the hypotenuse is always the longest side. And there's a formula. The formula is a squared plus b squared equals c squared. So if I said to you, well, I know that, let's use an example here. If I said, if A equals, let's say A equals, I don't know, let's make it 12. And if I said if C, let's see, C equals 15. What is B equal to? Okay, what we do is we plug those numbers into our formula. So if A is 12, we put 12 in there. We put plus B squared equals C is 15 squared. So here we are, we got 144 plus B squared equals 225. Okay, well, we want to find what B is, right? So we have to get rid of the numbers. on that same side. So we got to get rid of the 144 to get b squared by itself. So let's do that. So we got, it's a positive 144, so we minus 144 from both sides. There we go. So those cancel out. And I get b squared equals, okay, so what do I get for that? Let's just quickly calculate that. And so we got 225 minus 144 equals 81. Okay, but I'm not finished yet because I haven't found b. I've only found b squared. How do I find b? Well, to find b, I have to change b squared to b, which means I have to take the square root of b squared, and which means I have to take a square root of the other side. I do that, I get, oops, excuse me, that's not a b. I do that, and I get b equals, the square root of 81 is 9. So b equals 9. And there's my answer using the Pythagoras Theorem. So that's just one quick example. If you have any other issues, please see me with that. If you're not sure about how Pythagoras Theorem works, you should have done that in the past, though. Okay, so now we've got some vocabulary words we have to make sure we understand. First is a chord. A chord is a line segment joining 2 points on the circumference of a circle. So if I take and want to draw a chord, what I do is I just go from one, there's a chord right there. I can draw another chord. It can start and here and go down this way. As long as the two ends touch the edge of the circle and is a straight line and going across the circle, it is a chord. So those are two chords right there I've just drawn. Central angle and inscribed angle. Okay, central angle, first of all, is if I start, let's just change color here. If say this is the middle of the circle, that's about the middle. I'm not sure if it's exact or not. It's probably not, but a central angle is an angle that starts from the center and goes to the outside. Okay, and that's the central angle. That it goes from 2 points on the outside of the circle, and they both meet at the center of the circle. In other words, both of these two lines are radiuses. So the two radii I'm talking about here, there's one and there's another one there. They're both radiuses of the circle. They're halfway across the circle, each of them. Now an inscribed angle is an angle that once again starts at two different places on the outside of the circle. So let's do that. Let's draw one from here to here. But it goes to the, it's like a chord. It's two chords really is what it is. But those two chords, even though they start at different places in the circle, end up meeting at, they have a common point on the circle. So an angle formed by two chords that share a common endpoint. So this one here is an inscribed angle. So this is the inscribed angle right there, the blue one. Now the last thing here is arc, and the arc is the portion of the circumference of a circle. So an arc that the arc that this inscribed angle covers, or subtends we use, is right there. That's the arc, or part of the circle that one subtends or covers, and goes from one to the other. And this is, say, this angle here. That one is that's the arc of that one subtends or covers. Okay, and so those are the four vocabulary words. Just so when you see them in the textbook or you hear them mentioned in class or in a lesson, you'll know, have an idea of what it's talking about.